Okay, hello everyone. So welcome to our day four rocket camp. So today we are gonna go over some logarithm and also with some exponents. Okay, so for this one, the question reading is really easy. So just solve the logarithmic equation, which is log base 5 4 to the power of x minus 11 minus 1 uh, equals to log base 5 2 to the power of x minus 3. Okay, so first, let's go over some key point of the log. So if we have a log numbers, so log a base a to b equals to x. This one is basically the same thing as a to the power of x equals to b. So we just use this one as a log. So which means, yeah, so a will be our base numbers, and for the result of the log, which is x should be our exponents. And for this number will be our final number. So this one is equals to b. So we just change this exponents into another form, which we call the logarithm. Okay. And we also know one thing, and actually the calculation is really similar to the exponents. So if we have something like this, so if we have some log a to the power of b minus log, if they have the same base number, basically you can combine this log into B over C, something like that. And same if you have a plus, then which means you can multiply this final results. Okay, so what we have for this one? So I'm gonna change another colors. Let's see, maybe use this one. Okay, so this two part is just the review of the key point of our log. Okay, so right now let's do the questions. So we have log base 5 4 to the power of x minus 11. And this one should equals to the log base 5, 2 to the power of x minus 3. Okay, so for this one, so first, because we have a number that is not log, so what about we just change it to the log? Okay, so our first step is basically change our log. So we have log 5. So we can also change it to the same log for the easier calculation. So how to change 1 into log base 5? So 5 to the power of 1 is just equals to 5. So 1, you can change this to log base 5 or 5. And this one, you have a log base 5, something like that. Okay. And then you can combine these two numbers. So you will have a function like this. Okay. So that's what we have. And we have some things to represent these log functions, log equations. Okay. So first, we already know that the log numbers, the real number in the log must be positive. So which means because our base number is 5. Okay, so which means this number is basically positive than 0. And we also know this one is basically positive. And would we know what? We also know about after we cancel the log, because they all have the same log numbers. So basically 5 to the same power of things is equals to these two. So actually we should know about that. We have this one over 5 is also equals to this one minus 3. So this is the three equations or inequalities we can get. Okay, then our next step is basically to solve this one. Okay, let me change another color to solve this one. So let me change green. So first we have this one minus over 5 is equals to this one minus 3. Okay, so first we can just move 5 to the other side. So we have this one minus 11, and we have 5 times 2x minus 15. And we can get the special thing, which is 4 to the power of x minus 5 times 2 to the power of x. It's basically equals to minus 4. Or you can also switch the order, it doesn't matter. Okay, then our question changes to how to solve this exponent equation. Okay, so first, what is the relationship between 4 to the power of x and 2 to the power of x? Yes, the 4 to the power of x is basically equals to 2 to the power of 2x. Okay, then which means we can do something to that. So let's just assume, let me still use the green colors to change it. Okay, we just made another variables that u, something u equals to 2 to the power of x. Then we should know u squared is basically equals to 2 to the power of 2x, which is 4 to the power of x. So this one we can just use substitution method. We just change 4 to the power of x, 2 to the power of x to the u something. Okay, then we should have something like this. So u squared minus 2u. Oh, actually it's not 2u. Equals to 5u equals to negative 4. So this one will give us u squared minus 5u plus 4 equals to 0. So we can use cross method to factorize these equations. So basically we have u minus 1 times u minus 4 equals to 0. So we should know u is either equals to 1 or 4. All right, so what is our u? Yeah, our u is equals to 2 to the power of x. So we have two possibilities. If u equals to 1, this gives us 2 to the power of x is equals to 1. So which gave us x equals to 0. And another one is u equals to 4. We have 4 to the power of x equals to, oh no, actually not 4 to the power of x. 2 to the power of x equals to 4. So we have x equals to 2. Okay, so then we just check. So can x equals to 0? If x equals to 0, which means 4 to the power of x is 1. 1 minus 11 is negative 10. Can 5 to the power of something equals to negative 10? No, if you, for example, 5 to the power of negative 2 is not even equals to negative numbers. So a positive number's exponents cannot be the negative numbers. So which means this one we cannot use it. So can we use x equals to 2? Yes, so 4 to the power of 2 is 16. 16 minus 11 is still greater than 0. And the 2 to the power of 2 is 4. 4 minus 3 is still equals to 0. It's still greater than 0. So which means we can use x equals to 2. So the final answer will be 2. Okay, so this is the whole thing. And thank you for watching. I'm gonna see you tomorrow.